Welcome to CodeRage 2025. I will be talking about working with job objects. My name is Stefan Nyland. I'm a long-time Embarcadero MVP, and the cover I'm working under is fixed by code, so you can find my blog on that. So, what is job objects? It's a Windows kernel object that manages a set of one or more processes. And it has existed for a very long time. I wasn't aware of it, and only because I had the need for handling a lot of child processes together as one. I found this thing, and apparently now since Windows 8 these can also be nested. For Delphi, it's wrapped within the WinAPI Windows unit, and prior to Delphi 12, and I will show that later, the flag, gray process flag that is needed actually was missing from the WinAPI Windows unit. So you had to define it yourself, like written here with the create underscore breakaway underscore from job const. The way to find job objects or to monitor them is actually because they're not out in the open as such, would be actually to download something like the Process Explorer from the sysinternal site at Microsoft. And by default, these are the jobs are not shown, so you would need to actually, as said here, under options color selection job, actually set that up. So I'll just show that here. So I have Process Explorer running, and so under options, configure colors, and notice what's going to happen now. There's a lot of changes here. So this actually shows the various jobs running, and you can see it's used a lot of places. I'll come back to that. So why are these job objects useful? Well, it will allow you to group processes into one, so they can be managed as one. Able to start and terminating all related external processes. They can be named, and if the main process dies, Windows will terminate all the child processes. As said, these can be nested since Windows 8, so a job object can have other job objects which again have child processes and so forth. It also contains accounting info, so that would be I/O, CPU usage, memory usage, and so on. And as you saw in the Process Explorer, it's been increasingly used because, well, you want to contain your application more like one application, even if it consists of many external processes, and it's very heavy used. It can also be associated with an I/O completion port, and that means actually if some of the limits I will come back to you have set on the job object is hit or exceeded, you will actually be notified by that. So on limits and notification on job objects, these can be set as on the CPU level, so that would be maximum processes active, the time, the CPU affinity if you want to have the processes running on a specific core or multiple cores, the rate control might want to throttle things down to test something. There's also, you can set the memory, the minimum maximum working set, the commit maximum network. You can control bandwidth. I/O would be the rate, read write a number of bytes. From the UI perspective, you could actually set up that it should not be able to outside the process access the clipboard or exiting windows or do window switching or so forth. So if a process is assigned to the job and it tries to exceed or change any of these limits, then the function call would actually succeed but would be ignored. So for instance, if you would try to exceed a function call to allocate more memory, and then the process that call would actually succeed, but it would be ignored in that case. So it wouldn't fail, it'll just be ignored. If an optional IO completion port is associated, as mentioned before, you'll get notification when limits are exceeded. So an example of jobs with limits. Here I've shown that the first one would be the VMI provider subsystem host job. And so that would actually, here see that there's a job memory limit on a gigabyte of memory. There's a process memory limit, and there can be up to 32 active processes. So to set these limits, you would need to set one of the following record structures, and then call the set information job object function on that. And we will see that in code later how it's done. And as you can see here, there's the Win API names in parentheses, but also the more friendly Delphi enumeration. The other example is a list of where there's more UI limits set. So the write on clipboard, read clipboard, user handles, the exit window, and so forth. And that would be on an Edge web browser instance on the web view. So in the first code example, which was originally what I used this for, and the reason why I wanted to do that is actually wanted to had a main program, and that we had a lot of other programs, and that we needed to remember to start these, and also if one of these processes or programs, external programs, died, we had no notification on that, and so we wanted to control the external process and then actually get their in this case the standard error stream back through a callback. So actually our main backend would know when a process was within its control object or job object would actually fail, and then by that way we could actually contain the whole application as such. In this example, I'll just execute a small C++ program that writes 10 times to the standard error pipe, and then after that it's going to terminate. So that will also show the early termination of the process without the main program having terminated it. And just to show what's to be seen within the Process Explorer, these are, because it might go a bit quick when I'm showing it. So this is actually showing how how it looks on the startup. This is the starting processes, the main program, and then the child process started, which is a console thing, and then afterwards, while it's running, it has the brown color for as it's a running job object, and then afterwards, when the child process terminates, it turns red and dies, and then it closes down. So let's go to Delphi and just show the example of the child process code. So this is the simple C++ program. So that will just, we can compile and run it, and then we'll just count these, print these out to the STDERR, and then afterwards terminate. And since this program is not written by us, we want actually to control this in some form. So for that reason, we will have our backend Delphi program, which is, this example is just a simple form that has a memo, and I can try to run this. And you'll see it's running here, and then we have the process, and in a bit it will close down and we will see these go red. So it closed unexpected, and it actually terminates the the child process. So let's look at some code. So the thing here is that we are actually only doing, we're having a form create and a form destroy. Form create actually creates a custom child thread, which we'll come back to later, and then it sets the on terminate on that child thread. And the did child terminate unexpected is just writing to the memo field. And then we have the structure. It checks if the child thread is assigned, and it frees up the child, and prior to that it sets the on terminate to nil, so we don't get the did terminate unexpected when we close it down. And we also actually wants to from the child process want to terminate the process from outside here, since we are closing this form, and that should actually close the process. And then we have a small function down here is locked child error, which is actually the callback on the create child. So I'll come back to that. So if we go to the child thread, this is defined in a separate unit. And again, here I was mentioning that is if you're using versions of Delphi prior to Delphi 12, you would need to put this const in, since it's not defined in the WinAPI Windows unit, which sometimes happen. Well, the Win SDK changes, but well, the wrappers are not updated. So the T on capture proc is a reference to a procedure with the value, so that would be the callback procedure. T child thread is inherited from T thread, and it has a get age process which function which return the process information. I'll scroll that, and then it has the send log, which is just calling the callback with the buffer we're reading. I'll come back to that again. And then there's the creation of the thread. It's fairly basic 3 thread. So a free on terminate is false. I store the command and the callback proc. And then the interesting part is, of course, the execute. So in the execute, we want to create a process, but the thing is, we need to set up some of the scaffolding before that. So we would need to set up the security attributes as normal in a create process, and we also want to actually create a number of pipes for the input and standard input and output, but also an extra set for the standard error pipe. So these are the handles defined up here, and so I start off creating the pipes, read and write pipe, security attributes, and the second type, the second set of pipes for the standard error. Then I fill the startup info, your standard handles, show window, hide window actually, and then after that I do create the job object. So the job object returns a native unsigned int, and the create object would have a security attribute, and we will skip that for now, and then it will have a name, and based on what context you're running that in, you might actually need to put some, if it's on a terminal server or whatever, you would need to actually put in global scope naming, or I'm not sure what it's actually called correctly. And when I have the job object, I would then set the limits. So the basic information will set the limit on so it would be killed on a job close. And as mentioned before, I fill the structure, the job limit infrastructure, and then I go and set the set information job object. With the job object, the type of the structure, which is the job info, which is an extended limit information. We can go to this and see there's multiple of these within the Win APIs, and that is as mentioned in the previous slide. And then we set the the pointer to the structure and the size of the structure, and we're all good. After that, now we have the job object. After that, we create the process. The thing here is that we would, and since we're doing the pipe with the standard standard error pipe, we need that. We would want to set the this parameter to true, because that is the inherited handles flag. So that you want to set to true in this case. And then we set the new flag, or a new flag, which is actually tied to the job object, which will do the breakaway from the job. And that is actually how a process is allowed, or how it's connected to the job. Actually, there is a lot of documentation on this also. So if that succeeds, we're back to actually checking if we get the F process info handle, and by that way we take the process handle and assign the process to the job object like this, and then we're actually all good. So now the process, our client, or our small C program, is actually now controlled within this job object. And right now we'll then just wait for this process to peek on the pipe, the error pipe, and see is anything coming through, and then we will synchronize to the sendLog function, which is down here, and that will call the callback with the message. As we saw, it was then putting all the standard error from the C program out to the through that, since it's read from the buffer. And then after, when the process is done and died, then the job object will terminate as such, and we'll see that. So I'll just try to run this one more time. Just move it over here. See, it turned green as the picture, and then it's running it 10 times. A note on this: I didn't wait for the. You could have done it nicer. I just don't wait for the character return line feed or anything. So you should, doing this this demo, it doesn't really matter. But as you can see here, we are now done. It terminated again, and the job actually finished. So, and actually doing it a third time, where I actually killing the program before it's done, just to show that this will now terminate again, turn all red, and gone. So. So the next example we're going to show is based on an example that Pavel Yusifovic is doing in his job objects YouTube video, and I will encourage you to see that, because it's actually one of the good and few materials out there on job objects, I think. And as far as I know, this guy is the co-author of some of this internal stuff. And the example is, I'm doing a limit on the job objects to only have max 2 active processes. So if I try to start a third one, that would actually fail. Also, to limit the job object, and the second thing is to limit the job object to maximum utilize the 10% of the CPUs. And that would mean that if I start 2 processes within the job object, then each could have 10%, or together they could only have the 10% of the CPU. As in his example, I will use the CPU stress program to illustrate the limits. That program is a newer version of what was in the sysinternals, and is also written by him. So the idea is that actually the program is actually attaching the CPU stress program within the job. So here we create the job, and then we put actually the CPU stress in as an process within the control of our job object. So back to the code. You just close this one down. We don't want to save anything, and then we take the demo, the second demo. So this is a console application, and it's fairly simple. We start off by, we want to have added a parameter which is actually the process ID from the instance of the CPU stress program. I'll just start the CPU stress program up, the utility, and that looks like this. In the top here you can see you have a process ID, and that is we are going to use and register when we start up our program. So that will actually start by creating a job object, take the param we put in, which is the PID, and then open that process. So we get the handle, and then we will assign this process to our job object. And from that, from there on, we can actually then set up the infrastructures to limit what our job object is allowed to do. So in this case, we will start off with the job object basic limit information, where we are able to set the active number of active processes. So here we only set it to 2. And then we also need to set the limit flag, and in this case that will then set, we need to set it to the limit active process. And as before, we will go in and actually then call the set information job object function with the job handle, the type of the structure, and the pointer to the structure and the size of the structure. And on the second thing here, I'll show one of the things first, but I'll explain both right now. The second thing we want to do is actually to limit the CPU rate to 10%. To overcome the floating point stuff, these structures has a multiplied by 100, so 10% is 1,000 and 20 would be 2,000. And then we again set the limit, and then we set the control flag. In this case, we want to set the control flag with the CPU rate control enabled, and also with the rate control hard cap, so it caps off when we reach the 10%. If we didn't put this in, it will actually use as much as possible, but it would be the first to suffer down to the 10% if we would have CPU usage exceeded. And again, we call the set information job object to set the size. And then we just, in this case, we sleep infinite just to be sure that it keeps running while we are testing this. So I'll just put in the parameter and run it. And we have this one, so that would be 3904. Save that, run it. And we will get a success here, which then now we're actually having control of this. Let's look at the Process Explorer while we're doing this. So here we have, need to find our our test application. So that should be somewhere. Let's see if you can find it down here. There we go. No, we actually want the CPU stress. This one. That's what we want. Process tree again. At the CPU stress here. And the thing here is now that we have the first thing we can check is actually that we are not able to start more than 2 instances of the CPU stress. And when you test this, you should use this newer version because Pavel has added some features, so it's easier to test job objects here. So what you can do is go in on the process and actually launch another CPU stress instance, which will be attached to the same job object. So we do that, and I have a second one here, which is all good, and then I will try to do a third one, which I should be allowed, and I'm not. If I close the first one, process, launch another, different on another screen, then it will happen. It will be allowed again, and I can't do a third one. So that would be the number of processes I'm allowed within. What would be interesting now to see is actually to see, let's take the task manager and get the details and get the CPU stress. Have these two up. You want to see the CPU utilization. We need to drive this up a bit. So I'll close one of these, set all the threads active, run them all, and also set them to maximum activity. So that should hopefully put the stress up a bit. So you can see it, the stress is actually running up around, yeah, it's toggling a bit, but it's going up and down and up and down. What we could do to make this wilder is, as you can see here, actually none of these we won't go over. It's around the 10% all the time. If I did start a new instance on here, this one, which isn't within the control of the I'll start all of these. I will set the activity to a maximum. We should get a much higher number here, right? So comparable with this one compared to the other one, this is under our job object control. This will actually only go to the 10% of the CPU usage. And then we have, if we try to, I'll just close this one. If we try to open a new instance of this within the control, we should see that these two in combined would be, I'll just set this up to start all threads, and I would also set the maximum to that. So these two combined should never go past the 10% of the CPU usage. Where are they? There I. So as you can see, it toggles around the 10 actually. So let's close this one down, and also close this one. Program, let's end this one. And we're kind of back. So that is basically the role of the job object and how to actually control and I shouldn't say encapsulate, but actually control all your external processes within a given container. So if we go back to the slides again, so this is what we saw. So where does this all then lead to? Well, everything seems to be connected. So actually in Windows 10 a thing called silos was introduced, and Windows containers, also called Windows containers. And actually silos are just the upgraded job objects. So apart from CPU and memory and so forth, they also have own file system, registry, and namespaces. So they're actually Windows silo servers or Windows containers. So a Docker can actually be a Windows container, a silo. So if you normally use Docker, I'm not an expert on that, but if you set the isolation, the parameter with the isolation processing, then that was actually started as a silo, and it's out. It's not within the topic of this this session, but I would say it's a bit related, since the job objects are. This is job objects, but just upgraded. And then the limit, you would normally set that through the runtime, the container runtime, which could be Docker, with different parameters. On the whole thing, you would expect something like this also to be in the Linux world, and in that the equivalent would be C groups or control groups. So. But I haven't done anything on that yet, so maybe that's to come. Links. There is the job object documentation. Well, I wouldn't say there's too much, but I guess it's sufficient. But like all other Microsoft or whatever documentation, you need to read up on it and yeah, understand and try it out. There's a link to the Process Explorer earlier. There's a blog post. I did a process session earlier this year, which also covered a bit of job objects. And then there's the video I mentioned from Pavel on job objects, and it's quite nice. And when you see it, you can see I shamelessly ported his example code from C to Delphi, because I think it was a very good example he was using. And there's a link to his CPU stress program. So thanks. That was all for me, and now back to Ian.